Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good. Very good. Happy New Year to you.
Happy New Year as well, sir. Thanks.
Thank you. So, today, what do you want to do?
I was hoping if you could continue with some mechanics-based questions, if that's
Sure.
all right.
Sure, no
Okay.
problem. So, do you have any, or should I share with you my questions?
Oh, I have yeah, a couple, but if you want to share your ones, I don't mind, sir.
Oh,
It
let's
just
begin with your questions and then let's
okay.
please share.
Poppy weighs p kg and Quinton weighs q kg. The system is in equilibrium. Show that to the nearest whole number, p plus q is 53.
Okay. So, this is not like one of those which you have done earlier. It's a unique question, Amy.
All right. That makes sense since I couldn't do it.
Yeah.
Yes.
Okay. So, what I think is we really have to work on all these pivots one by one. So let's begin from the left hand side. Poppy, who weighs p kgs, is 3 units away, right? 3 meters away.
Yeah.
Five is the total distance. Two is from here, right? So 3 units from the fulcrum, the first point. So because of that, the moment, which is a counterclockwise movement, will be how much? It will be so because of Poppy, the counterclockwise moment will be the mass into g into 3 units, correct?
So the moment will be 3 pg. Yeah.
3 pg. Now, as you know, moment is actually force into distance, right? So we
Yeah.
have moment, and now we have to basically work out what force will this exert at the center where Robert is standing.
Oh.
So we have to find the force at R, we can say, Robert. So moment is force into distance, as you know, and therefore, I should say right. So the force will be moment divided by distance, and that is the force. Now, in this case, the distance is 2 meters, right? So that is those many Newton meters, right? So
Hi,
if I
sir.
write this, yes,
Sorry, how come we're finding the force at Robert? Like,
because
why?
Robert is in equilibrium, and there are
Hmm.
forces which are acting from both the sides. So there is a force due to Poppy and due to Quinton. And
And
these
that's because there's
forces
someone in
in
the
the
middle.
center, yeah, these forces in the center are
Oh.
being balanced by Robert's force. You get the point. So when we
Oh.
balance them out, only then the system will be in equilibrium.
I see. All right.
That's the whole idea.
Yeah.
So basically, we are finding this force due to Poppy. Let me write FP. Force due to Poppy at R. Let me write P R. Poppy to Robert will be moment, which is 3 pg Newton meter divided by 2 meters, correct? So that gives us 3 by 2 pg newtons. Is that clear? The units also
Yeah.
match. Okay? Now, on the other hand, let's work out the other force, which is due to Quinton. So same thing here. So this moment is clockwise, which is Q times 3 times G, right? Now, this moment is exerting force at Robert. So this force due to Q at R is basically equals to the distance of 2 meters. So 3 qg divided by 2 meters.
Yeah.
So you can see here as if we now have two forces at this point which are acting upwards, which are due to P on R and due to Q on R. And the downward force is basically because of the Robert weight, correct? So they should be equal. So Robert weight is given to you as how much? 80 kg.
80 kg.
80 g becomes the force. That should be equal to sum of these two, right? 3 by 2 pg plus
Oh,
3 by 2 qg. Is that okay?
yeah, yeah.
So gg cancel, and what you're left with is 80 equals to 3 by 2. 3 by 2 is common. P plus. So we have to find what P plus G is. So now you can cross multiply. P plus G equals to 2 by 3 times 80. How much do you get? 160 divided by 3?
160 over 3.
Approximately it must be 53, okay?
Oh,
Yeah.
53.3, yeah.
153 will give you 159. So we have shown that P plus Q is 53, right?
Oh, I didn't really clock the fact that like Poppy plus Quinton would equal the weight of Robert downward. And I didn't know you had to find the force at Robert because I was doing it at the pivots.
Brilliant question, actually, because we didn't come across such a question earlier. So that's a very beautiful question, which you said.
Yeah, but in a different format. Yeah, but same things applied.
Same thing applied.
Yeah.
Earlier, you remember one gear question which we did, right?
Yeah, here.
Oh, this one. Yeah, here. This one. So this one also had the same principle. You remember? We worked out the moment due to this, correct? And then force, and then moment, right? And then force. Do you see that? So in this question also, yeah. So in this question also, we started from one side, right? I think I don't remember exactly, but I think we started with 10 kg.
Yeah, and then we worked through it.
We found the moment at this particular point, and once we did the moment, we found the force, correct? Acting at this point, which is a common point, because of that moment, correct? And then because of this force, we found the moment here, and that moment has to balance out with this hanging weight. You get the idea. So last time we did this question, which is
so when we did this question, because I didn't actually understand that last part where so we found the forces at the both pivot, like both of those turning points, but then did we make them equal each other for the center?
Yeah, no, at this point. Oh, okay. Shall we go through it again?
I feel bad, sir, but
Just
yeah.
few basic
Okay, sure.
We'll not do calculation. We'll not do calculation, okay?
Oh, okay, yeah, because I didn't really get.
So let's say these were two masses. Okay, this mass is unknown. Because of this mass of 10 kg, there will be a moment here, right? So the moment, let me call this moment 1, which will be equal to the mass of 10 kg, means 10g, into distance of 8, correct?
Yeah.
Now, this is acting in the center, this point, which is 10 units away. So the force acting at this point will be 10g into 8 divided by the distance of 10, correct? So which makes it 8g.
Right.
Now this force will now cause a moment here, which will be clockwise. So the moment, which is clockwise moment at this point, because of the force 8g will be 8 into distance of 5.
How come it doesn't go
5 is this distance, right?
anti-clockwise?
No, because this force is acting here, right? So this moment, yeah, because the gear, this side is up, this side is down. The gears are moving, right? Their movement reverses this force.
Oh, yeah. Oh, yeah. Okay.
Yeah, a good question. So now we have this force 8 into 5 here, right? Which is the moment, right? So force is a moment m2, let's say. Now this moment will cancel with this force, only then this will be at equilibrium. So that should be equals to m times 2. So the answer for m should be 8 into 5 over 2. 4 times 20.
So
So
it's got
that
to
is
be
how
right
we translated the moment into force, force into moment, moment into force, and then equated with the.
Yeah.
So beautiful question. And I think these two questions are quite similar
Yeah,
to
they are.
one another concept wise, right? And you do see this 10 marks here, right?
Oh yeah.
So they are heavy. Very good selection. So I'm happy you could get such questions, right? Hmm. So Pearson, Edexcel, AS, A level mathematics. Good job.
For a
Correct.
teacher, not
Hmm.
for a student. Wait, sir, just on the moment for the second one.
Yeah.
So why are we not doing like we did on the right hand side? Like we've only got 8. Where did the G go?
With G. With G got cancelled, right?
Oh, did you just do it quickly?
No, did I do? Oh, I missed it. Wait. I think you have a point there. Oh,
Oh,
G 8G is there, right? Yeah, 8G is there, force. And therefore, this force was acting. So the moment, yeah, 8G, G is there. I'm sorry. G is there.
oh, okay.
Yeah,
No, I was
and
just wondering. Yeah.
yeah, now you have to multiply by G. Correct. Yeah, I missed that G. Correct. So
Over.
because of that G, I missed that number. So the moment will be G will be here, right?
Is it times 2 though?
Yeah, times.
Like the moment, because you wrote 5.
No, because the 5 is the distance from here to there, right? This small gear is 5 units long. Radius is 5.
But
So when you
if
convert
we
the
do.
moment to force,
Oh, I thought the mass was attached to the 2 centimeter one.
yeah. So that is on the right hand side. So look here. So this 2 centimeter is equals to 8 into 5 into G, correct? So now, yeah, so G and G cancel. So G and G cancel. And we get M as 8 into 5 by 2. Yeah, G and G cancel. Well, let me
Wait,
redo
so,
it.
yeah.
Let me redo it. Okay, let's
Sorry.
start from the beginning, right? So let's
Yeah.
start with this force, right? And moment because of 10 kg, right?
Yeah.
Will be, since it will be in this direction, clockwise. Is it okay?
Yeah.
And this is 10 g into 8, correct?
Yeah.
Now, because of this moment, we have a force at this point, correct?
So force at that point.
Force at that point will be the moment divided by distance.
Moment over distance. Yeah.
So 10 g 8 Newton meter divided by 10 meter. Is it okay?
Yeah.
8 g Newton. Is it clear?
Yeah.
Now, because of this 8 g Newton force, we have a moment here, right? So this moment here is that much into the distance of 5 units. 8 g times 5 Newton meter. Is it okay now?
Oh wait. So moment equals force times distance. So we got the force and we're timesing a distance of 5.
5, which is the gear.
Oh, I didn't see that. Yes. Thanks, sir.
And now that should be equal to the moment which is counterclockwise due to m kg, right? So m
Yeah.
into g into the distance of 2, right? And these should be equal. You get the idea. So we have our equation, which will be mg2. I'm purposely writing not 2mg. And just because we have got numbers
Hence.
in between, it is easy for me. Right? Okay.
Yeah.
So
Yeah.
now we cancel this g, right? And we get the value of m as 8 into 5 divided by 2. That means 20 kg.
Oh. Yeah, I didn't understand it before. Now I really get it. Thank you,
Good,
sir.
good, good.
That's so clear. Yeah,
Yes.
because it's really hard because number one, like gears, the way it moves, it's like you need to know about the rotation. And then finding forces in the center, like I've never ever done questions like that before. I didn't even know like that even exists. So yeah, obviously once you find that, then the whole formula of force equals like moment equals force times distance works.
Yeah, moment is force
Wow.
times distance. Simple
Thank
as
you,
that.
sir.
Or force equals to moments over distance. Done. This is
Legendary.
important. And you check with the units. It is good practice to write units along with the numbers you have. So that helps you to
Right.
check, are we using the right formula? Did we miss out something? So those
Yeah.
are kind of important, correct?
Yeah, that's very important. Thank you so much, sir.
Yeah, clear.
Been at this question for a while. Yeah.
Correct.
All
So
right.
now you can take some other question.
Okay, I'll keep it related.
So we have this one where we have an inclined plane and we have some friction also here, I think. Yeah. So the question here is a rod AB of length 3A and weight W rests on a peg at C, as shown in the figure. The end A of the rod rests on a rough horizontal ground, making an angle of theta with the ground. Find the normal reaction on the rod at A if AC is 2A. So we have a peg here. So this is one of the questions which you shared earlier. So I'm just sharing back with you.
Oh,
Let's see if you remember how you solved it.
um, I didn't even know I had this question. Sorry, I've done a lot of questions. I'm really like I'm
Yes, yes.
forgetting.
That's why I reminded you, kind of, right?
Oh,
So,
okay.
Amy, do one thing. We have done a lot of videos on moments. I'd like you to go through them once in a sequence. And of
Okay.
course, the two which you asked today, right? They are different concept, right? And
Yeah.
this one
Yeah.
also is very unique, and that's why I took this up. Now it involves coefficient of friction. So here we have this rod, and the numbers are like 3A and 2A, correct?
Mm-hmm.
So I would like you to actually attempt this particular question, right?
Huh?
And if not, then look into one of our previous videos and find the solution.
Oh, yeah. Yeah. All
Okay.
right.
So
Mm-hmm.
I'll quit this for now, and let's look into
Oh,
more.
I actually do remember. Like it was
Remember,
something to
right?
do with mu, and yeah, mu equals r. No, mu force equals mu r.
Mu, yeah. So force equals to mu r, one thing, force, okay.
Yeah,
So
because we
you
haven't
remember,
used that formula at school, so I
yes,
just
yes,
did it with you. That's why.
yes. Force equals to mu r. And second, wherever you have to find this force, you have to find the reaction, right?
Right. Right.
That
So
that is
that
actually key.
a
So
yeah.
that is the concept here which you have to use and then get to the solution. Is it okay?
Okay. Yeah, I'll solve and then I'll send it to you.
Yeah, yeah, yeah. So I'll stop sharing. We can continue with your questions.
All
Okay.
right. Okay. um, these ones. I feel like we did that question.
Okay.
Yeah, and we might have done this one as well. So we can start here.
Okay. So
All
can
right.
you please read the question?
Yes, I can. So a non-uniform rod AB of mass m and length 5d rests horizontally in equilibrium on two supports at C and D, where AC equals dB, which equals small d. So as shown in figure 5, the center of mass of the rod is at the point G, and a particle of mass 5/2m is placed on the rod at B, and the rod is on the point of tipping about D. So part A show that GD equals 5/2D.
Okay. So we have this
Oh,
rod whose mass is m and length given to us is 5d. It rests horizontally as shown. Everything else is now clear, right? Now we have to work tipping at D, right? So when we are tipping at D, basically what is happening? So before tipping, it is in equilibrium. Is that okay?
yeah.
Just before tipping, it is in equilibrium.
So before tipping, it is in equilibrium.
Yeah.
Yeah.
So now,
So do we just do the moments at D?
yeah, we do moments at D, right? So the moments because of B is what? Into B, correct?
Yeah, so 5/2 mg times d.
Yes. So this is being balanced by this moment, correct? Because otherwise, this you have to ignore this at C. You get the idea? Because
Right.
all other things are now ignored. It's like slanting. That is not touching. You get the idea? So it is lifted from C, but because of the mass at G, it is still pulling it down. So only moment is
Oh,
acting because of G. So because of G, the force, the moment will be what? Because of G, it is M, and the distance is how much?
wait, so it's got nothing to do with C.
Nothing to do with C.
Okay.
Correct. So the total length is 5D, and G is how much away? Where is G?
G is there.
You get it?
C to D is 3D.
Mhm. You can't read it. Okay.
Oh,
Just
sorry. Should I enlarge?
no, just you read and tell me. So
Oh,
the
okay.
one
So
unit AB mass M5D rests on the horizontal equilibrium at two supports C and D.
did it just move?
Yeah.
Oh, sorry.
No problems.
Oh
GD,
no.
okay. GD is not known to us. Okay. Get back to the question. It says GD is not. We have to find GD. Correct. No problems. Get back to the question.
I was trying to enlarge it for you, but I
No,
think
no, no.
it
I
would
read
have
it.
moved.
Right. We have to find GD.
Oh no, but the diagram went.
Okay, I'll erase and we'll redo. Don't worry. So
No, but
get
the
the question.
document itself has.
Oh, I see the document.
Oh no. Oh wait, it came
You
back.
got
It
it. You
came
got it.
back. So
Good.
it
Well,
wasn't there. I swear.
okay.
Okay.
Yeah, let's now do it. Yes, and it's absolutely clear. Andy. Thank you. So, what have we given here? That the rod is uniform, whose mass is m, and it is acting at g. So we'll put m here. Is it okay?
Yeah.
The support C and D, where AC, DB, ADB is D, so those are at D distance away. The center of the mass of the rod is at point G. A particle of mass 5 by 2 m is placed at B. So here we have a mass, which is 5 by 2 m.
Yeah.
And the rod is on the point of tipping about D. So it is tipping about B. So when it is tipping about D, you have to ignore all other reactions. The only thing which is now acting is the center, the mass at G. Is it okay? On the other side.
Yeah.
So we have to equate the moments at D. So moment at D because of B is what?
5/2 mg
Yeah,
times d.
times D. And now we have to find the moment at D because of G. How much? So
But
this
how do you find the distance?
that is what we have to find, right? Show that
Oh,
GD is that much. G to D distance is X. Let's say X. Okay.
okay.
So it is M times X.
Mg times
Mg times
d.
X. Yeah, that's why. Mg times X. Correct. Now both should be equal since this moment is in the direction counterclockwise and that is clockwise. So they should
Right.
equate, right? So we have moment because of GD equals to moment because of BD, right? So we have mgx equals to 5 by 2 mgd, correct?
Yeah.
So clearly mg and mg cancels, and x value is 5 by 2d. So that's what we need to prove, right? We have got it.
Oh, that was actually relatively straightforward.
Yeah. But you have to realize
Nice.
that other forces are not acting in this moment. Yeah.
Yeah, that was the part that I didn't realize because I was trying to work from C and then do it to D, and I thought all the forces act on. So do you just mind repeating why pivots at C don't act on it and just G and B.
Okay. So when we are talking about tilting, think like this. Let me just redraw as if it is tilted, right? So if I redraw this rod, if tilted, do you see what is happening? This
Yeah.
support is no more there. You see that?
Oh, it's like off. The only thing that can hold
It
it
is
down
off.
is that G
The only
force.
thing is the weight of the rod itself, which is holding at this moment.
All
It's
right. Yeah,
good to
without you drawing
visualize.
it like that, it's really hard to see.
So you have to
Visualize.
visualize. It is just tilting.
Yeah, that's nice. Thank you, sir. That's really clear.
Okay, good. Yeah.
Wow.
Part B, find the magnitude of normal reaction between the support at D and the rod. Find the magnitude of normal reaction between the support at D and the rod. So now we have to work out the reaction at D.
Yep. Just writing a quick point. Other forces
Okay.
at C don't have
Yes.
impact or anything else. Okay, that was just, I was just drawing your diagram because visualizing it like that was very important. Okay, cool. Thanks, sir. So part B, the particle is moved from B to the midpoint of the rod, and the rod remains in equilibrium. Part B, find the magnitude of the normal reaction between the support at D and the rod.
So that means now we know that the distance between G and D is known to us, right? So
Yeah.
we'll actually redraw this, right? And then do the needful. So let me clear this. Okay. Correct. So then we'll redraw, right? So now what we have learned is G to D is given to us 5 by 2D, right? So this distance is 5 by 2D. Is it okay?
Yeah.
So this is given to us now. Now the question is, the particle is moved from B to the midpoint of the rod, and the rod remains in equilibrium. So midpoint means 2.5 away, right? So midpoint is kind of here, right? So here, that 5 by 2 mg is acting now in the center. Is it okay?
Yeah.
So that is force. And this, we know the center is acting here. And this is m, right?
So when they say the center, that is where you place the 5/2 mg.
Yes, yes. Which is
But G is
2.5,
still the place of
2.5
mass.
d, 2.5 d from the ends.
Oh, okay.
Correct.
Oh, right.
Now it says find the magnitude of normal reaction between the support, because now it's in equilibrium, right? At
Right.
D and the rod. So we want normal reaction at D. We want this force.
Oh.
This is what we want to figure out. So how will you find reaction at D?
So this is a force. So we will have to do moment over distance. Like the normal reaction force equals the moment, which we're going to calculate out over the distance. But now it's moved, so we can just use, because we know that G to D is 5/2.
Mm-hmm.
I don't know. We can find that distance between that center where you put the 5/2 and D.
Okay. So,
But because it's in equilibrium, we need to like make two equations. You know, the anti-clockwise and clockwise equal.
Right.
But we need to think first about how to approach.
So we can find forces at which, let's say we try to find force at C. Because we don't know what is the reaction at C, right?
No.
And we want to find the reaction at D, correct?
Yeah, we want to find.
So what we can do is we can find the moments about point C.
Oh, because it will cancel.
Yeah.
Oh.
So if we do that, then because of the rod weight and the mass in the center, these will contribute clockwise. Is that okay? So the clockwise, because they are clockwise, right? Clockwise moments are because of G, which is, I should write M because of G at C. We are working out at C, right? Plus
Yeah.
moment because of the center, which was at B, that other mass, right? Small mass. So let me write down small mass at C. That should be equal to the reaction, which is now counterclockwise. Moment for D at C. Is that okay? So that will give you.
Wait, sorry, what was the moment at G to C?
So, okay, we will calculate. I'm just written the equation.
Oh
Moment
yeah, I know,
from
but
G.
where is it on the diagram? Like G
Here,
to
here,
C.
here. This one.
But then what's M to C?
Okay, that is
Is
the
it
other
not
one.
the same?
No, this is M to C. That's which you have placed 5 by 2G.
Oh, is your M that midpoint?
Okay, yeah, at midpoint. Yes.
Oh, the M stands for midpoint. I thought it meant that M, and I was like, oh, that's the
Okay.
length.
Oh, yeah.
Sorry.
No, sorry. So, okay. So what is the distance between C to G? We know G to D, that distance is 5 by 2M, right?
Yeah. Moment from G to
G to D is 5 by, sorry, what did I do?
Oh wait, no, that's the mass, not
No.
the distance.
No, it was show that GD is 5 by 2D. G to D is 5 by 2D, right?
Yeah, so from that midpoint to D, it's 1.5D.
That means 2.5, right?
Yeah.
This is 2.5. Right? Correct? And so now, what is the distance from C to G? This is what we have to find, right?
Mm.
So let's calculate here. CG. CG is how much?
Well, A to C is D, and G to A. Oh no, wait. M to A is 2.5.
So we
So
can. So 5D is total, right? In this total, we have to take away these 2Ds, right? Minus 2D. And then we take away GD, correct? Which is minus 5 by 2D. Is it okay? 2.5. So we get GD, CG.
what?
Shall I make it again? I'll make a drawing. Right? So we have the point A, we have a point C, we have a point G, we have a point D here,
Oh
and
yeah.
we have a point B, correct?
Uh-huh.
Now, what we really know here is that from A to B, let's do it from A to B is 5D. Is it okay?
Yeah.
And this is 1D. This is another D. And this is from G to this is 2.5D, right? Correct?
Yeah.
So the remaining is how much?
I'll subtract 5D from all of that.
Yeah, 5D minus all of that, right? So 5D minus D minus 2.5D minus D. Is it okay? So
0.5D.
Yeah, 4.5D. So which is 0.5D. Is it okay?
Oh, yeah.
So CG is 0.5D. Is that clear to you?
Mm-hmm.
So therefore, the clockwise moment in this case is because the mass m, g, the distance is 0.5d.
Yeah.
Plus, because of the center mass placed 5 by 2 mg, weight being this much, distance being, because it is in the center, right? So from center it is
1.5.
1.5.
Oh.
That should be equal to the reaction at D times the distance from D, which is 4D, right?
But how can we find the like
sorry.
moment from D to C?
Sorry, not 4. 3. How do
But
what is the
we
question?
don't. Oh, sorry. Like when we did the forces and the clockwise, because the reaction at D is going upward.
Yeah.
We're doing R times.
R times the distance CD.
Oh yeah, that's going anti-clockwise. Sorry. Yeah, got it.
This distance CD is 3, right?
Yeah.
Because D and D there, correct? 3D.
Oh yeah.
So 3D. Now we have an equation, right? Only unknown is R. D's will cancel, correct?
Yeah, these will cancel. And
we have to find the magnitude normal reaction R. Okay, so we can now calculate reaction. So let's calculate D from our calculations and now figure out, divide by 3, right? So we have 1/3 of, so 0.5 and this is 2.5 times this, calculate.
Oh yeah, so I got
0.5
0.5 plus 3.75.
and this is 2.5.
Oh, you took half outside.
1.5.
Yeah, you did differently.
MD. Yeah, what do you get?
0.5 add 2.5
times 1.5.
4.25 in the brackets times a half.
No, divide by 3. Why half I have written? 3, sorry, 1/3 R.
Oh, it's getting like 1.416666 recurring.
Okay, that should be good.
Oh,
so let me do it. 0.5 plus 2.5 times 1.5. Okay, divide by 3. What do you get?
For 1.4166.
1.416 is correct. R equals to 1.4166. Yeah, this is what I get. Perfect. So as I find the magnitude normal reaction R supported by this on the rod. So 1.4.
What happens to the M and the G? Do we not multiply?
Yeah, MG. Sorry.
Oh. Do we times it by? Do we leave it in terms of G?
Yeah, it will be in terms of G. Yeah, I see.
Oh, okay.
Sorry.
So how do you know when to multiply the G by 9.8?
Always. 9.81.
Oh, okay. Or so, if it doesn't say, you can just leave it in terms of G and it'll be fine.
Yeah.
Okay.
It doesn't say. Find the magnitude of reaction between. Better to multiply by G. Okay. Leave it in terms of M.
All right.
Yeah.
Thank you, sir.
What do you get now?
Oh.
Okay, that's fine. That's fine. So
sorry.
you have understood, right?
Yeah. No, I've got it. We got the answer. I can just do the last bit. Yeah. It's fine. The steps, the hard steps.
I wanted to leave it even much before that. But
sorry, Phil. I know mechanics is hard. It's a hard one.
No. Because I have so much limited space there. It becomes very difficult for me to look here, there, put things everywhere.
Definitely.
Yeah. So you should do it in systematic way so that you don't miss MG and all those things.
Right, because you can't be like flying from one side to the next. It has to be
because there is a text underneath, right? So I'm writing on the text, so it gets mixed up, and the text is in black, and my writing is much lighter than that.
Yeah.
It makes no difference, right? So okay,
that's true.
Anyway, you actually shared very good questions, all were of different kinds. So I hope with this, your concepts about moment and your review must have been, consolidated, and you should be good at it.
Yes, definitely. It was so useful because Yeah, no worries, sir. Because
Right.
those are the little gaps in like moments. Because I understand like the basics, but applying those basics to the questions we saw today, which we do, is just turning your head in a different like way of approaching, which I found a little bit tricky. So obviously needed your guidance, but thank you so much, sir. That was
Thanks, my
helpful.
pleasure. It was a learning for me also. Thank you. Yeah.
No worries,
Take care.
sir.
Enjoy
I
your
hope
leave.
yeah, enjoy the rest of your day, sir. I'll see
Thank
you soon.
you.
Bye, sir.
Thank you. Bye.